Hello everyone. Today I am going to explain about dual simplex method. Dual simplex method. Now they will ask one problem. To do one problem in dual simplex method, whatever we did in simplex method, quite oppositely we have to do. How to do and all I will tell you. Now here the first problem is apply the dual simplex method to solve. The first problem is minimization of z is equal to 2x1 plus x2 subject to the constraints. The first constraint is greater than or equal to 3. Second constraint 4x1 plus 3x2 greater than or equal to 6. Third constraint x1 plus 2x2 is greater than or equal to 3. x1, x2 greater than or equal to 0. The constraints are given like this. To do one problem in dual simplex method, the objective function must be in the maximization type. If it is already in the maximization type, keep it as it is. If it is not maximization type, convert that into the maximization type by multiplying both sides with -1. Then you can convert into the maximization case. And the next thing is, to do one problem in dual simplex method, all the constraints must be in the form of less than or equal to. Or if already it is in the form of less than or equal to, keep it as it is. If not, convert the greater than or equal to symbol into less than or equal to symbol by multiplying both sides with -1. Remember these two things. If it is in the maximization type, do not touch, keep it as it is. And if it is not in the maximization type, you convert that into the maximization type by multiplying both sides with -1. All the constraints must be in the form of less than or equal to. If not, convert that into the less than or equal to form by multiplying both sides with -1. Remember, now these two are the conditions to do one problem in dual simplex method. Now we will see. Now given problem is in the minimization type. Now subject to the constraints, all the constraints are having greater than or equal to symbol. All the constraints are having greater than or equal to symbol. Therefore, first we will convert the objective function to the maximization type and constraint into the less than or equal to type. We will convert the objective function in the maximization type and constraint into the less than or equal to type. Now how can we convert that into the maximization type? Multiplying both sides with -1. W is equal to -z. Minimization becomes max. W is equal to -z is equal to -2x1 -2x2. If you multiply both sides with -1, -z is equal to -2x1 -x2, you will get -z is equal to W. If you take max W is equal to -z is equal to like this. We converted so many times subject to the constraints. Now greater than or equal to symbol is there. I am converting into the less than or equal to symbol by multiplying both sides with -1. If you multiply the first constraint, with -1, -3x1 -x2 greater than or equal to becomes less than or equal to -3. Second constraint, multiplying both sides, second constraint, because having greater than or equal to symbol, multiplying both sides with -1. -4x1 -3x2 greater than or equal to becomes less than or equal to -6. In the same way, third constraint also, x1 x2 greater than or equal to 0. That means the minimum points to satisfy the dual simplex method, we satisfied the 2 points of the dual simplex. Now after that convert the given this one into the standard form. Now we will convert this problem into the standard form. Standard form again, what is the rules of the standard form? Max W is equal to it is already in the maximization case, that's why keep it as it is. Now less than or equal to symbol, if is there in any, you have to add one slack variable. If it is less than or equal to symbol, you have to add one slack variable on the LHS of the constraint. Now second one also having less than or equal to symbol, therefore we have to add one more slack variable called S2 on the LHS side. Third constraint is also having less than or equal to symbol. We have to add one more slack variable called S3 on the LHS side of the constraint. After converting into the standard form, we will get like this: x1, x2, s1, s2, s3 greater than or equal to 0. This is the standard form of the given problem. After converting into the standard form, using this standard form, we will form the table. Now the table of dual simplex. I will draw the table of dual simplex. The table of dual simplex contains CB column as usually. We draw in simplex also CB column, B for basis column. Now body of the simplex table, how many variables are there here in our problem? How many variables are there? x1, x2, s1, s2, s3, 5. That's why x1, x2, s1, s2, s3. x1, x2, this is s1, s1, s2, s3. x1, x2, s1, s2, s3. We have 2 variables and 3 slack variables, s1, s2, s3, and xb. There is no minimum ratio in dual simplex. Do not draw minimum ratio. xb RHS column, RHS values. To write the RHS values, one more column called xb column. Now this is the body of the simplex table, this is the xb column. Now we will fill the body of the simplex table using this matrix. Now Cj is equal to, using the objective function, we have to draw Cj. Cj is equal to minus 2, minus 1, 0, 0, 0. Now body of the simplex table I will write minus 3, minus 1, 1, 0, 0. xb is minus 3. Second one, minus 4, minus 3, 0, 1, 0, minus 6. Minus 1, minus 2, 0, 0, 1, and here minus 3. Draw one line like this, one more line like this. This is the index row. Now we will fill the basis. Now if you close this one, the 2 variables is variables. If you close these 2 variables, wherever you get identity matrix, 1 0 0 0 1 0 0 0 1, the above elements will become basis or basic elements or basic variables. Wherever identity matrix forms, that variables will become basic variables or simply basis. Here s1, s2, s3 is there, that's why B stands for basis. s1, s2, s3. Now above s1 how much is there? 0. Above s2 how much is there? 0. Above s3 is how much is there? 0. That's with 3 zeros. Now here zj minus cj. This is the zj minus cj. To calculate the index row elements, the formula is zj minus cj. Now as usual, zj minus cj. Now zj minus cj elements, how to calculate? This into this, 0 into minus 3 plus 0 into minus 4 plus 0 into minus 1 minus cj element, this element. How much you will get? Now this is initial simplex table, that's why quite opposite values only you will get 2, 1, 0, 0, 0. Why? Because this is initial simplex table. Now this into this plus this into this plus this into this minus this element. 0 into anything is 0, that's why 0 into anything is 0, plus minus of minus 2 is plus 2. Now here also 0 into this one plus 0 into this one plus 0 into this one minus this one is equal to 1 here. In the same way, for all elements you have to do 0 into this one plus 0 into this one plus 0 into this one minus this. Like this if you do, you will get the simplex 2 element. Now in the dual simplex method, when will you reach optimality? In dual simplex method, when will you reach optimality? If all the xb elements greater than or equal to 0 as well as all the index row elements, means zj minus cj greater than or equal to 0. That means all the index row is greater than or equal to 0 as well as all xb is greater than or equal to 0, then only we will reach the optimal condition. We reached the optimal condition and we can write it. But here minus 3, minus 6, minus 3 is there. That means with the solution is not optimal, we have to go to the next iteration. Whenever this xb column is greater than or equal to 0 as well as all the index row elements greater than or equal to 0, we can stop the iteration and we can write the optimal solution and we can write max z or min z, whatever. Now Here XB column, if you observe, minus values are there. That's why the solution is not optimal. We have to move further. To move further, how to proceed? I will tell you. Quite opposite to the simplex. In simplex, first we will see index. After that, we will see the minimum ratio. Now here, first we have to see the XB column and then index row. Coming to the XB column, first go to the XB column. In the XB column, the most minimum, the least and the most minimum, least value or minimum value in the index row, the minimum -3, -6, -3. The minimum value is -6. That means I choose the second row. Second row I choose. Now after choosing the second row, if you observe the second row, wherever negative elements are there, just identify the negative elements. Just remember, in these two places only, first place and second place only, we have negative elements. The remaining and all we don't want. Only we need negative elements. Now this index row element, whatever is there, that index row by this negative element. Wherever, for example, here and here we have got negative elements. That's why index row by -4, 1 by -3 we are doing. For suppose here positive value somewhere, negative values if you get, wherever you get negative values, that only you have to see. Only negatives only we have to see. What is the formula? I will tell you. I will show you the formula. The formula is minimum of. You have to write the formula is minimum of within flower bracket. The first value is modulus of. Inside of the modulus, what you have to write? Wherever negative, choose row. Whatever which one is the choose row? Our choose row is second row. In the second row, negative values occurs in -4, -3. These two are the negative values. 2 by -4 in the first place, 2 by -4 comma, the next value is wherever negative is there, that one we should write 1 by -3. Here first second we have got, that's why first and second we are writing. For suppose here two positives and somewhere negative values, wherever you get negative values, only negative values we should write. Now the minimum of 2 by -4 and comma in modulus of 1 by -3, 1 by -3. Now to modulate within a minimum of, within modulus negative also will become positive. 2 by -4 becomes 2 1s are 1 by 2 comma, within modulus -1 by 3 also becomes 1 by 3, 1 by 2, 1 by 3. Out of these two minimum is 1 by 3. Out of these two minimum is 1 by 3. 1 by 3 means second place. Second place means this one. Now minimum which place we have got? First place and second place. Minimum 1 by 3 is the second place. Second place means this one. That means here we have to second place. That means here you have to put one arrow. If you put arrow, the coincide element is here. If you come like this, the coincide element is -3. Put one box here, -3 is there. Now what we have to do with the -3? -3 is the pivot element. So that S2, if you come like this, S2 is leaving variable, whereas X2 is entering. That means S2 is leaving the basis, and whereas X2 is entering the basis. 0, S1. The first, these two elements I won't touch. The second one, S2 is leaving the basis and X2 is entering. Above X2 how much is there? Above X2 -1 is there. And 0, S3 also I will write as it is. Now like this, S2 is leaving variable, we left that S2, and X2 is entering variable, we entered X2, and above X2 -1 is there. Now what we have to do with this pivot element? We have to convert the pivot element just like simplex method. What we have to do with the pivot element? We have to convert the pivot element into 1 and above and below elements into pivot element into 1 and above and below elements into zeros by doing some elementary row transformations. How to convert this into 1? Divide the whole row with -3. -3, if you divide the whole row with -3, -4 by -3 is 4 by 3. 4 by 3, 1, 0 by anything is 0. 1 by -3, -1 by 3 is 0. -6 by -3 is 3 1 3 2s are 2. Now the above element into 0. We have to convert the above element into 0 by doing some elementary row transformations. Whatever the row we are going to convert into 0, first that one I will write minus 3, minus 1, 1, 0, 0, minus 3. Which this element I have to convert into 0. This element occurs in the first row. That's why I wrote the first row. After that, this is the old row. This is called old row. Now the new row, whatever, after converting the pivot element into 1, whatever you have got, that is a new row, that one. This one I will write 4 by 3, 4 by 3, 1, 0, minus 1 by 3, 4 by 3, 1, 0, minus 1 by 3, 0, 2. Now in the second place we have to get 0. To get 0 here, shall I add or subtract? If I add, then only I will get 0 here. Minus 1 plus 1 cancel 0. Now LCM is 3. I am adding 3 minus 9 plus 4. 1 minus 1 by 3 is 0. Minus 1 minus 3 plus 2 is minus 1. Minus 9 plus 4 is minus 5 by 3. Minus 5 by 3, 0, 1, minus 1 by 3, 0, minus 1. And the next, this element I have to convert into 0. That element in the third row, I will write the entire third row. Minus 1, minus 2, 0, 0, 1, minus 3. Now this is the old row. This row, complete third row I wrote. After converting the pivot element into 1, whatever the row you have got, that one new row I will write again. 4 by 3, 1, 0, minus 1 by 3, 0, 2. Now which element I have to get 0? Second element. To get 0 here, what should I do? To get 0 here, I have to multiply the new row with 2. I have to multiply the new row with 2. Now minus 1, minus 2, 0, 0, 1, minus 3, as it is L, right? The new row I am multiplying by 2. 2 4s are 8 by 3, 2 1s are 2, 0, minus 2 by 3, 0, 2 2s are 4. I multiplied this row with 2. I have got like this. Now if to get 0 here, what should I do? I have to add. I am adding. 3 LCM is 3, minus 3 plus 8, 0 here 0, minus 2 by 3, 1, 1, minus 3 plus 4 is 1. Minus 3 plus 8 is 5 by 3. Now here, this element in the third row we should write. Minus 3, 0, 0, minus 2 by 3, 1, 1. Now index row. Again we have to Zj minus Cj, Zj minus Cj. Now how to find the index row elements? To find the index row elements, this into this, Cb into x1 plus minus Cj. This into this plus this into this plus this into this minus 2. That one. Like that you have to do the simplifications. 0 into minus 5 by 3 is 0, minus 1 into 4 by 3 is minus 4 by 3, plus 0 into 5 by 3 is 0, minus of minus 2 is plus 2, and if you simplify, how much you will get? 2 by 3. Now this one, 0 into 0, 0, 0, minus 1, minus of minus 1 plus 1, 0. Again here also 0, 0, 0, minus 0, 0. Now here you will get here how much you will get? This into this plus this into this plus this into this minus 0. How much you will get? 1 by 3 and 0. Here minus 2. Now shall we stop the iteration and shall we move further? Shall we move further or shall I stop here itself? Because if you observe, all the index row elements are greater than or equal to 0, but here XB column contains one negative. That's why we did not reach the optimality and we have to move further for the next iteration. Here in the XB column, the most minimum is, most negative is minus 1. Put one arrow. That means I choose the first row. Now after choosing the first row, what we have to do? Wherever negative elements are there, just observe the negative elements only. Minus 5 by 3 and minus 1 by 3. Now what we have to do here? Negative elements. Now minimum of 2 by 3 by minus 5 by 3. Minimum of 2 modulus of 2 by 3 by minus 5 by 3, comma, and another one is 1 by 3 by minus 1 by 3, 1 by 3 by minus 1 by 3. Wherever negative elements are there in the chosen row, that only we should write inside of the minimum. Now 3 cancel, minus becomes plus 2 by 5 1, 2 by 5 1 out of these two, minimum is 2 by 5, 2 by 5 is in the first column, that means first column. That means if you choose the first column means here like this you have to put arrow, minimum of like this you have to find. After that the 2 by 5 is the first column minimum value, that's why I chose. Now the coincide value is this one, therefore this is the pivot element. Pivot element, what we have to do, that means here S1, if you observe, S1 is leaving variable, whereas X1 is entering. Above X1 minus 2 is there, X1 is leaving, S1 is leaving. In place of S1 we will get X1, above X1 minus 2 is there. Now X2 minus 1 as it is, I will write 0 S3 as it is. S1 is leaving, whereas X1 is entering. Above X1 minus 2 is there, that's why minus 2. This X2 minus 1 as it is I wrote from the above, and S3 0 as it is I wrote. Now what we have to do, we have to convert the pivot element into 1 and the below elements to into zeros by doing some elementary row transformations. Now minus, if you divide the whole row with minus 5 by 3 you will get 1, minus 5 by 3 by minus 5 by 3 1, 0, 3 by 5 minus 3 by 5. Now here how much you will get, 1 by 5, 3 get cancel, minus cancel, 1 by 5, after that 0. Now minus cancel, 3 by 5. Now I am dividing the whole row with minus 5 by 3, so that you will get like this. Now this element into zeros by doing some elementary row transformations. To do these elementary row transformations, first we have to write the old row. What is that old row? 4 by 3 1 0 minus 1 by 3 0 2. Like this old row I wrote, and a new row, what after converting the pivot element into 1, whatever you have got, that one is the new row, that one. 1 0 minus 3 by 5 1 by 5 0 3 by 5. Now in which place I have to get 0? In the first place. Here I have to get 0. To get 0 here, I have to multiply the new row with 4 by 3. If I multiply 4 with 4 by 3, then only, and then if you subtract, if you multiply 4 by 3 and then if you subtract, then only you will get 0 there. Now 4 by 3 1 0 minus 1 by 3 0 2 as it is, right? 4 by 3 into 1 is 4 by 3 0, 4 by 3 0. Now 3 cancel, minus 3 cancel, minus 4 by 5, 4 by 4, 1 by 5 into 4 by 3 is 4 by 15, 0, 3 cancel, 4 by 5. Subtracting. While subtracting, you need to change the signs. 4 by 3 plus 4 by 3 0, 1 minus 0 1, 4 by 5. Now here LCM is 15, 3 5s are 5 into 1 minus 5 minus 4, minus 9 by 15, 3 5s are minus 3 by 5 0. Here LCM is 5. LCM is 5, 10 minus 4, 6 by 5. Now, if you do the simplifications, you will get like this. 0, 1, 4 by 5, minus 3 by 5, 0, 6 by 5. Now, next one. In the same way, next one, if you write this one and then the next one if you write and if you simplify, how much we will get? 0, 0, 1, minus 1, 1, 0. Now we will find the index row elements. Index row elements are minus 2 into 1 is minus 2, plus minus 1 into 0, 0, 0 into 0, 0, minus of minus 2. How much you'll get? 0. Now this into this, plus this into this, plus this into this, minus this. How much you'll get? 0. Now if you simplify this into this, plus this into this, plus this into this, minus 0 is how much? 2 by 5. This into this, plus this into this, plus this into this, minus 0 is how much? 1 by 5. 0. Here minus 12 by 5. Minus 2 into 3 by 5 plus minus 1 into 6 by 5 plus 0 into 0. How much you'll get? Minus 12 by 5. Now if you observe all the xb column, all xb's greater than or equal to 0 and all zj minus cj is index row elements, all zj minus cj greater than or equal to 0. Therefore the solution is optimal. Now coming to the problem, if you see the standard form, what is there in the standard form? Max W. In the standard form, what is there? Max W. Max W is equal to minus 12 by 5 at x1 is equal to 3 by 5, x1 is equal to 3 by 5 and x2 is equal to 6 by 5. But in the standard form, max W is there. That's why we wrote max W is equal to minus 12 by 5 minus 12 by 5 at x1 is equal to 3 by 5, x2 is equal to 6 by 5. But given problem, what is our given problem? Our given problem is min z, not max W. Therefore, min z is equal to minus 12 by 5 is there. If you multiply with minus 1, how much you will get? 12 by 5. At x1 is equal to 3 by 5, x2 is equal to 6 by 5. This is the answer. Like this you have to do this problem. Thank you very much. You have to do this problem like this. Thank you very much.